Good day, everyone. You're welcome once again to Master Lectures, and today's video lesson will be for 200 level students in the University of Benin, offering this course called Start 201. So if you're a university student or you're among any of these federal universities or university in Nigeria, all right, and you are offering a statistics course, all right, for university students, it is known as Start 201. So this will just be an introductory lesson to hypothesis testing. This is an introductory lesson to hypothesis testing. Now, hypothesis testing is one area where you see lots of questions from, right? This is one area that examiners don't actually joke with when it comes to statistics. Okay, so we're looking at hypothesis testing. Now, this is just going to be an introductory class, right? But a lot is going to be said. Now, let's go. For the first one, hypothesis testing can be defined as you trying to analyze an assumption made about the population parameter. That is hypothesis testing. So a statistical hypothesis is an assumption made about the population parameter. So when somebody make an hypothesis, all right, you can just come up now, for example, and say the number of obese girls in University of Benin is not greater, or let's say it is not less than 70%, or the average mean of obese girls in Uniben is not less than 25, or is not more than, let me use the word, is not more than 25, all right, 25%, for example. So what that simply means is that not being more than, all right, that's just an hypothesis testing. Okay, so that is what we refer to as a null hypothesis. So that null hypothesis, it can be tested, all right. So in you trying to test that null hypothesis, if it is correct or wrong, is what is now referred to as hypothesis testing. So the general assumption that is made is the null hypothesis. Then you trying to test, all right, trying to confirm if this thing is true. That is what we have as hypothesis testing. So that is why we have two things. So when somebody gives a general assumption, all right, just like the example I illustrated before, okay, so you cannot be like, it's not true, or let me verify if it is true. So the act of you trying to verify is hypothesis testing. So that will now lead us to two types of hypothesis. Now we have the null hypothesis. This is that the population parameter is not different from a particular value, right? This is that the population parameter is not different from a particular value. So when the population parameter is not different from a particular value, you just say it is the null hypothesis. So that is why I gave an illustration. If you now give, say, not less than 25% of girls in University of Benin are obese, for example, okay. So it means not less than means it can be more than, but it can be more than, all right, but it will not be below 25%. So you can have like over 25%. Now that thing I just made, that's a null hypothesis. So I'm trying to say that the population parameter is not different from the particular value I gave. All right, so that's a null hypothesis. But what then? Now the null hypothesis is also referred to as the hypothesis of what? No difference. Hypothesis of no difference. So if this is my hypothesis now, all right, the illustration I gave was proven to be true, then you now say yes, it is correct that not less than 25% of girls in Uniben are obese. So, but let's that is it for that. Therefore, alternate hypothesis is just like the arguments that you bring. All right. So for alternate hypothesis, it states that there is a significant difference between the parameter and a particular value. So you cannot say, this thing, how can you say 25% of girls, not less than 25% of girls in Uniben are obese? So no, I don't agree. That's the alternate hypothesis. All right, I don't agree. So that is what the alternate hypothesis says, that the particular value, that value you are bringing, all right, there is a difference of that value with the population parameter. So based on population, all right, I cannot say no, that value is wrong. Okay, so that is the alternate hypothesis. Now, please take note, whenever the null hypothesis is rejected, the alternate hypothesis is accepted. If you reject your null hypothesis, what happens? You accept the alternate hypothesis. If you reject the alternate hypothesis, you accept what? The null hypothesis. So if you fail to reject, now these are terms you'll be seeing in your examination. If you fail to reject the null hypothesis, it means you have accepted the null hypothesis. Like, I failed to refuse money from somebody, it means I collected the money. Alright, so when you fail to reject, it means you accept, and when you fail to accept, it means you reject. Please take note. When you fail to reject, it means you accept. When you fail to accept, it means you reject. So if I say I fail to accept the null hypothesis, it means I rejected the null hypothesis. I fail to accept null hypothesis means I rejected the null hypothesis. I fail to reject the null hypothesis, it means I accepted the null hypothesis. So if your null hypothesis is accepted, it means that your alternate hypothesis will not be accepted. Okay, but if your null hypothesis is rejected, it means your alternate hypothesis is what? Accepted. So it's like a two-way thing, they are antagonistic. If you are accepting null hypothesis, you are rejecting alternate. If you are rejecting null hypothesis, you are accepting alternate. That is the way it is. Then, now, what is a type 1 error? This error occurs when a true null hypothesis is rejected. So when you reject a true null hypothesis, something that is true, alright, a statement that is true, an hypothesis that is true, and you fail to reject that hypothesis, that is what they call, and you fail to accept, you fail to accept that null hypothesis. So remember I told you, failure to accept is you rejecting, and failure to reject is you accepting. Okay, so how do you commit a type 1 error? When you fail to accept a true null hypothesis. So not all null hypotheses are true. That's one thing you must know. Null hypothesis is just telling you that there is no significant difference, alright, between what is observed and what is expected, or you see there's no difference between the population parameter and a particular value. So that is it for null hypothesis. So you can have a false null hypothesis and you can have a true null hypothesis. So when you fail to accept a true null hypothesis, you have committed an error known as what? The type 1 error. Please, the type 1 error is also known as the alpha error. Type 1 error is also known as what? Alpha error. Then type 2 error. This error occurs when the false null hypothesis is accepted. When the false null hypothesis is accepted. So remember, under null hypothesis just tells you that there is no significant difference, alright, between the population parameter and a particular value. But now when you make a true, when a null hypothesis is true, alright, and you now fail to reject that true null hypothesis, and you now fail to accept a true null hypothesis. When a null hypothesis is true and you fail to accept that true null hypothesis, you have committed a type 1 error, also known as an alpha error. But when a null hypothesis is false and you fail to reject, meaning you accept it, alright, it therefore means that you have committed what? A type 2 error. A type 2 error is also known as what? Beta error. So a type 2 error is also known as a beta error. Now, what then is level of significance? The level of significance is the probability of committing a type 1 error So the probability or the chance, all right, of you committing a type 1 error, the probability or the chance of you rejecting in every statistical hypothesis, there is at most cases, all right, there is always a certain percentage, all right, there is always a certain level of chance that a true null hypothesis will be rejected. A true null hypothesis will be rejected. So remember, that's the type 1 error. So the probability, the chance of committing a type 1 error, all right, the chance of failing to accept a true null hypothesis, it is called level of significance, all right, and the level of significance in most calculation is taken to be what? 5%. 5%, or you see 0.05. Please take note of that. So it simply means out of 100%, it simply means out of 100%, there is a 95% chance that you are going to accept the true null hypothesis, and there is also a 5% chance that a true null hypothesis is going to be rejected. So for every statistical hypothesis, all right, there is a 5% probability, a 5% chance that the null hypothesis will be what? The true null hypothesis, all right, will be rejected. That is it for level of significance. All right. Then lastly, we have what is known as the critical region. This is the region in which the null hypothesis is rejected. The region in which the null hypothesis is rejected is called the critical region. All right. The region in which the null hypothesis is what? Rejected. It is called the critical regions. Now, when we get to calculations, all right, you'll be seeing things like, okay, for example, you have this, something like this, for example, and then I put something here and I put another one here. Now, these edges here, they are known as what now? Critical regions, and any value that fall around here, all right, the values in this area, they are known as critical values. So here is the critical region. So if you do a calculation, all right, and your value fall within this critical region, what happens? You reject what? The null hypothesis. It means you have to reject the null hypothesis. So the critical region, it is a region in which the null hypothesis is rejected. So by calculation, anything you are doing and it is falling around this critical region, so what do? You simply what? Reject the null hypothesis, right? You reject the null hypothesis and accept the alternate hypothesis. Now, null hypothesis is represented using HO, H naught, right? Null hypothesis is represented using H naught, while alternate hypothesis is represented using HA. So null hypothesis is represented using H naught, while alternate hypothesis is represented using HA. Alright, so this is where we'll just come to the end of today's lesson. It's just a brief introduction. Please take your time to understand this little information. It will be very, 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 very vital and essential by the time we get into calculations. So thank you very much for watching. This is Mastery Lectures. Please do it to like, share, and subscribe. Thank you.